Hello. I was on time today.
Were you really?
I was early.
Yeah, this is second time. And I don't like it.
I had to go to the office. Not this time. I do it to get in trouble this time. One of my first hours is something like really complicated.
What, how long would it take to start?
Yeah, it's not super early.
They call, they're like, they start, if we wait longer than 6 minutes, they call it an
It's
accident.
like never at home.
No, because in the program, we get
Literally, 6
Like, we got
minutes.
here about 6 weeks.
You all can be late, because we're gonna
Which one do you
They used to call my mom every day. She got sick. I don't
like
know. Literally, I mean, I'm the block the number. It's not our job to be in school on time. I just don't.
What?
As a senior, it's not your job to be here on time. It's your job to be.
No.
That is.
You know, you can't come here every day. And
I know exactly.
Got you.
I bet there's some people that disagree. I don't.
Alright, good. I just feel like, why do you call every day? Don't call my phone. That's weird. Call me. I don't care. I'm only late here.
Okay, guys, ready? So yesterday, this is where we were at the end. Okay. This is where we were at the end of yesterday. We had 4 terms. Okay. Give me one term. What was the first term we talked about yesterday? Mass was one. What was the other one? Weight. And good. Volume. And okay. Did we get like basic rough understandings of all of these, or not all of them?
Not all.
Not all of them.
Yeah.
Oh, we didn't talk about density yet.
We didn't? Are you sure?
Yeah, we spent too much time talking about it.
Too much time talking about? First of all,
That was useful.
you can never spend too much time talking about space.
Well,
We had a nice discussion about that in AP Lang this morning. too.
wait, we do want to go on.
Again?
What was I talking about?
Because Mr. Byrne was the one who was asking the class, he was like, you better ask Mr. Patton about that one, because I have no idea. So then I asked, and then we talked about it again.
It's cool.
Do we wait time to get
No, we have to read 3 sample essays,
Overweight.
write our own essay.
Ethan, what is the mass? Did you write it down yesterday?
Amount of matter contained.
Amount of matter contained in an object doesn't change its gravity.
Now, I'm just going to write it a little differently because at the end of yesterday, we started talking about matter. We're going to start representing them as like individual particles. Now, again, we know that they're atoms, but we can't draw all the atoms. We're just going to represent them as particles. Does that seem reasonable? All right. It's the amount of particles in an object. I feel like that's very reasonable. Is that cool? All right. What is the weight?
effective gravity? Object.
Right, it's the effective gravitational force, right? So basically, this is how heavy something is. When you say something is heavy, you're talking about the weight. Okay, you're talking about the weight. What is the volume?
Amount of 3D space.
So we're talking about how big something is. So when you look at 2 objects, if you say this one's bigger than this one, it has a larger volume. Is that cool? Now, what about this one here? You said we didn't get this yesterday?
No.
Okay, so at the end of the class period, we were playing with my little blocks here, okay? And when you look at these 2 little blocks, what do you notice about them? Something very important. What do you notice about them?
Same size.
Okay? One's metal, one's plastic, and more importantly, they are the same size. So what would you say about their volumes?
The same.
Okay, so I'm gonna draw them on here, okay? So we'll say that this is the metal one. we'll say this one is the plastic one. And when we put the plastic particles in yesterday, when we put the metal particles in, tell me what you notice about these two. There's two things to notice. Tell me one.
One of them has more particles, which indicates that one is going to be.
Okay, so I'm going to tell you what she said, because she has money in the bank on this. And she says, this one has more particles, which means it has more mass, and it is also heavier. Do you guys buy into what Zaria's selling here? I think that's 100% correct. And if you hold these in your hand, you can feel that. Okay? You can feel that. Tell me something else about the two drawings that might not be quite as obvious. Okay? It might not be quite as obvious. Yes, they are different colors, that is true. But be specific. Like when you look at the particles in there, what do you notice?
There's a less amount.
Okay? There is less, go ahead, Abby, nice and loud.
The one on the right, the plastic one is more spaced out.
Do you guys see what she's saying here? She said if you look at these are less compacted, they're more spread out than these particles here. Is that true?
Yeah.
I mean, do we have an everyday term for like when you take something and you like compact it into a small space versus you let it spread out? Okay? Would you say something was more tightly packed? Would you say it was more dense than something that's more spread out? Is that true or is that not true? Is that part of your everyday language?
Yeah.
So these are more tightly packed than these. So what is the kind of qualitative you're going to say? You say this one, these are more densely packed than these? So if they're more densely packed, you say it has a higher density? Okay? So then, what are we going to say about density then? Okay? What are we going to say about density? All right? Check with the neighbor, come up with like a general definition for it that goes with what we're throwing down here. All right? And I don't want an equation. An equation doesn't really help us understand things. We need a conceptual definition.
I would say it's like,
I think it's about I don't know
Right here.
how jam-packed it would be.
I
Jam-packed.
think the metal's more condensed. That's what we used to talk about.
Oh,
And also like,
you hit me,
because
man.
density is like the relationship between mass and volume. When you have the same volume, but the metal has more mass.
Oh,
It would then be like more dense. Right, but in relation to volume, but the volume is the same. That's what
All right, Isis. And lightness. Oh, I'm sorry, do you know answer?
Not really, but I will.
Oh, no, I don't want
Okay. I don't want to.
to. That is totally fine.
I mean, I will if you need me to.
Someone want to share their density definition?
You heard mine.
All right, I'll do it.
Go ahead.
Okay. I said that density is like the relationship between mass and volume.
It absolutely is. Okay? We're gonna talk about that in a second. I wrote that it's a measurement of how tightly packed the particles are within an object. Does that seem okay? But what does that mean? If they are more tightly packed,
It's more dense.
it's more dense. I mean, consider like, in this classroom, you guys are free to spread out as much as you want. What if we took this classroom and we just made it, forget the back, just the classroom part. What if we made it half the size? What's gonna happen to your spacing between you guys?
It's got more contact.
It's going to. And what if we made it even half that size? What's gonna happen?
it'll be hot in here.
Okay, you guys are going to like have to get more tightly packed in. The density goes up. So, we know this one is more dense because there's more mass but the same volume. So when she said it's a relationship between those, I feel like that's a great way to say it. Is that cool? In a technical sense, I think if you wanted to calculate the density, it's actually a ratio of those two things. It's the ratio, you guys know what a ratio is, like a division? So, in this case, if you have more mass with the same volume, you'd have more density. Is that cool? What I like about this though, okay, what I like about this is let's compare these two. Same piece of metal, okay, same piece of metal. Which do you think has a larger density? Which do you think has a larger density? Check with your neighbor, see if your neighbor knows. Which of these two has a larger density? Check with your neighbor, see if your neighbor knows. I'm not trying to trick anybody.
I said,
It's equal.
I said, I think the cube would be.
For the weight?
Because.
No. To me,
Why are you playing with my toys?
oh, he snitched.
Can you put that back where it goes, please?
I don't know where to go.
All right, Chris, which of these you think has a larger density?
Only 6 now.
You think they're the same? Anybody want to agree or disagree with the same?
I agree.
You agree?
Yes.
Tell me why.
I second that.
Well, it's the same piece of metal, it's just like one smaller than the other.
Yeah, but,
Do we feel it?
It's the same thing.
I just.
okay. Jane, what do you think? I'm asking you what you think.
It's just like a hot and ready. You have a stack of 4 and a stack of 1.
It's just like hot and
It's still a hot and
ready.
ready, it's just less hot and ready.
I actually agree with your pizza analogy here. Okay? I actually agree with your pizza analogy here. If you look at the way that I drew this picture, this is the small one, this is the large one, true? If the density is a measurement of how tightly packed they are, what do you notice about how tightly packed these are compared to these tightly packed here? It's the same, right? But what I like about this is that this one has a large mass and a large volume. This one over here has a small mass and a small volume. So this is like 10 over 10, this is like 2 over 2.
But they're both 1.
But they're both 1. Is that all right? All right, fantastic. All that is slightly ancillary to what we're going to do today. Okay? I have this object right here. Okay? This is an object. I think it's made of aluminum. I think it's made of aluminum. I don't actually know what it's made out of. Okay? I don't know what it's made out of. Let's pretend it's aluminum for now. And when you look at it, okay, Brooklyn, what does that say right now? Now, it says 1000 G, but she has absolutely correctly identified the fact that this says 1000 grams. So when it says 1000 grams, what is that grams a measurement of? You guys know?
The math.
No, it's the weight. No, it's the math. I don't know.
It is 100% the mass. Okay? Now, in your chemistry class, you might measure mass in grams. In here, even though this says grams, we're going to measure in kilograms. Okay? We're going to measure everything in kilograms. Now, do you guys know what this word kilo means? You know what kilo means?
It's less than 1,000. It's 1,000 times 1,000.
Okay, so that means 1,000 grams is equal to what? 1 kilogram. Is that cool?
Oh,
Yeah.
All right. So what if I had then 800 grams? What would that be? 0.8 kilograms. And what if I had 500 grams?
0.5.
Now, what I like about this
No.
is 0.5. Is that like a half? Is 0.5 a half? Is that true? So when I look at this one says 500, this one says 1,000. Is this one half this one?
Yes.
It's literally half the number of particles. Like a paperclip has the mass of 1 gram, which means if I took 1,000 paper clips and I compressed them and I wadded them up, this would be 1,000 paper clips. This one would be about 500 paper
Half
clips.
thousand.
Is that cool? So today you guys are, and from now on, you're only going to work in here you're only going to work in kilograms. Is that cool? So, what you guys are going to do today is you are going to take this and you're going to compare the mass and the weight. Here, you hold these two. All right? So read them. Which one says it has more mass? Oops, sorry.
This one does.
All right, what's it say on it?
1,000 grams.
It says 1,000 grams. Is that cool? So how many kilograms is that? 1 kilogram. What's the other one?
500.
500. So how many kilograms is that?
2.5.
Half. That is correct. So